Think about the synthesis of this target. Step 1 is to consider the functional groups in the molecule. In this case, there's just one. It's an azide. And it's important to notice that it's attached to a primary carbon. So there's a CH2 there. It's important to notice that, of course, because the only way you know to make azides is using an SN2 reaction, and SN2 reactions work best at primary centers. Step 2, as you think about planning the synthesis, count the number of carbons in the target molecule. Well, this has 5 carbons in the ring plus an additional carbon, so this is a C6 molecule. And step 3, take a look at the materials that are in your starting materials pool. What compounds are they? And it turns out that they can have as many as 6 carbons, so it looks like you probably won't have to make a carbon-carbon bond. If you're careful about what you pick as starting material, you probably are only going to have to do functional group manipulation. And then you can set about the process of thinking about what this could come from. Well, we've already mentioned that this is going to be an SN2 reaction that substitutes azide in the place of a good leaving group, and bromide's a good one because we know how to put it in molecules. Well, we need to know how to make a primary bromide then, and although we could make it with an SN2 reaction, that's not going to help us because we need to functionalize that carbon. If we had a good leaving group there other than bromine, we'd have to figure out how to put that there. So let's think about other things, and in fact we know how to make alkyl bromides by adding HBr to an alkene. So it seems reasonable to say, as our next planning step, that this could come from this alkene. And this alkene is something we would make by elimination. Well, it could be elimination of HBr, couldn't it? Because we know how to make tertiary alkyl bromides, we would suppose that this comes from a tertiary alkyl bromide. And we know that tertiary alkyl bromides can be made selectively if we have an alkane that only has one tertiary position. So this alkane is a good precursor. And it's an alkane, it has only 6 carbons, so it fits the description of the pool of compounds we have as starting materials. And this lays out the synthesis. What remains to be done is describe the synthesis from beginning to end. So let's do that, writing down the reagents. So we know that selective radical halogenation at a tertiary position is accomplished using bromine with light. We can eliminate HBr from that in a 1-2 elimination that selectively takes a proton off the less substituted carbon if we use a bulky base. So now we have an alkene that we need to make the bromide we want if we do an anti-Markovnikov addition using HBr with a dialkyl peroxide. And finally, as we've mentioned, if we treat this with sodium azide, an SN2 reaction occurs at a primary position that displaces bromine by azide. So there you have it. We start with methyl cyclopentane, and in 4 steps, we have our alkyl azide.